Here I'll be talking about electric field at the center of an arc. So electric field at the center of an arc. Obviously we are considering arc is uniformly charged. Suppose that we have an arc like this, and suppose that this is the center of the arc. This is the center of the arc, and I'm assuming this arc subtends an angle alpha, total angle alpha. So now I want to calculate the electric field due to this arc. Obviously charge Q is uniformly distributed, uniform distribution. So we want to know the electric field at center. So what you need to do, let us take, this is an R, radius of the arc. Suppose that I took one element which has dx length and which subtends a d theta angle. Due to this element, electric field dE will be in this direction, right? And simultaneously, if I am taking the similar element here at same angle, let's say same angle, this theta, and I'm taking the same angle but in the opposite direction, the same element dx, then it will be having this electric field vector dE. So suppose that if I assume this as theta, right, this as theta, then this will also be theta. So we can write here, what I can write, let me draw this diagram separately. So if this is dE and this is dE, this is theta, this is also theta, so I can write this is dE sine theta, one component, and similarly for other one also dE sine theta, and dE cos theta and dE cos theta. This will give you 2 dE cos theta, correct? So E dE net will be is equal to 2 dE cos theta, right? And now I want to calculate the total electric field. So E net will be is equal to integral of dE net. If you substitute the value, you get dE cos theta, and obviously you can write the value of dE here, which will have k dq upon r square. So I'm assuming this dx element is having dq charge. So now our task is to calculate the value of dq. dq will be lambda dx. This lambda will be linear charge density, correct? So now if you see this small element which is consist of d theta angle, so from here I can write d theta is equal to dx upon r. So from here dx will be is equal to r d theta, correct? So here I can substitute these values. So k into lambda and dx will become r d theta upon r square. This is cancelled out, so we got k lambda into d theta upon r. This is the value of dE. So we can substitute the value of dE in order to calculate E net, which is going to be 2 k lambda into d theta upon r into cos theta. And for limits of theta, so here this particular segment will have q by 2 charge and this will also have q by 2 charge, right? So if we have considered two elements, then only for one element we need to put the limit. So theta will vary from 0 to alpha by 2 because total angle is alpha, so this angle will be alpha by 2. So limits will be from, for theta angle, limits has to be 0 to alpha by 2. So now if you solve, first of all you can take constant outside, so 2k lambda upon r will be outside. Cos theta we have to integrate 0 to alpha by 2 into d theta. So we can use here integration 2k lambda by r into cos theta will give you sin theta, and if you put the limits it will be sin alpha by 2, correct? So we got the value of E net. Now we have to convert this E net in terms of Q, total charge. So how to do that? So of course we can define lambda is equal to total charge divided by, let's say this arc has s length, so s we can write in terms of alpha. This s will be given as we know that alpha will be s upon r, so s will be alpha r, so this will be alpha r. So here we can substitute the value, so E net will be is equal to 2k upon r into q upon alpha r, this is the value of lambda, and sine alpha by 2. So if you substitute this, rearrange it, then kq upon r square into sine alpha by 2 upon, this can be written as alpha by 2. This alpha can be written in denominator, right, like this. So I hope you got the point how to calculate the electric field. So this E net is nothing else, E at point at the center. Okay, so that's how we calculate the value of electric field for an arc which is uniformly charged. Okay, yeah.